Can you hear me now, maybe?
I can hear you perfectly now.
Oh,
I
great.
think we're back. I
Great.
think we're back. Okay, great. Well, let's just keep going with that. I'm going to bow out and yeah, please do continue. So I think we're good. Thanks. Sorry, folks.
Yeah. Yeah, so today's or tonight, depending on your time zone, streaming with Brian will be about a small project I've built for my scuba diving club. And it was a Blazor static web app to actually do exams online. So maybe, Ryan, the first thing we can show is actually the GitHub repo.
Sure.
So I will copy paste the link if you want to check out on your side. So first warning is a very early stage project. So as you've seen on GitHub, I've started to work on this project 2 months ago, and actually I'm working on a V2. So you have a bunch of branches. There is no README on that project. It's terrible. I definitely need to fix this. But I wanted to show you how I built this project quite quickly while ensuring this project is secure. Because I'm actually using it for a real purpose. But when you want to secure exams, there is a lot of issue you need to solve actually to create this secure environment. So when I say secure, you may have different levels and requirements of security. As I said, I've done this for my scuba diving club. Like a lot of different clubs, we almost shut down during the lockdown, but we continue to do some, theoretical training with Microsoft Teams, and we wanted to get these students to pass their exams online. So when we can go back together on the sea, we can just dive and not worry about all these exams. So Brian, do you want me to maybe show the final project before we dig into the code and the architecture?
Absolutely. We do have one question. I think you might cover some of this at during the course of the session, because it's still early, but WQ Walter is asking, what are some of the steps required to go from ASP.NET to MVC Core 2.2 to be able to use client-side and server-side Blazor? So I'm assuming you'll cover some of that in this session, but feel free to jump in and answer that if you're...
Sure. So if you're already on an ASP.NET MVC Core, that's already good news. For one reason is within the Blazor apps, and actually maybe I need to introduce first Blazor because maybe some of the viewers actually don't know what is Blazor. So maybe we should start with that. So Blazor is a quite new framework we build on top of .NET that allows you to build client web app by using C#. So when we mean client web apps, we mean apps that run in the browser and build with C# and not build with JavaScript, which is one of the main reasons I've tried to use Blazor for this project, because I'm doing programming for more than 10 years, and that's my fault, that's me, but I can't figure out my head out of JavaScript, and I really love C#, so that's why I decided to basically use Blazor. So what you can do with Blazor is actually create interactive web UIs. So for example, when somebody is clicking on a button, you can have some code that reacts to this. And there is actually two execution modes of Blazor. The first one, and the first that has been launched, is a Blazor server-side. What does it mean? It means that actually you are developing your application as it was an interactive web UI application, but from an execution perspective, when you click on a button, a message is sent through WebSocket to a server, and the actual processing is done on the server. It's interesting from a developer perspective because you don't have to deal with a lot of different things on the web side of things. But the fact is you need to actually have good connections, and some scenarios like progressive web apps, app that runs offline on the browser, cannot be used if you use Blazor server-side. But since last Microsoft build a few months ago, we announced the final release, like the first production release of Blazor WebAssembly. So WebAssembly is an open standard that is implemented in a lot of different web browsers that basically allows to run an assembly language within the browser sandbox itself. That means that you can actually write C# code that will be executed on top of WebAssembly on the client side. So you can do a lot of different interactions without having to touch at any point the server. And that's one of the very cool things I love about Blazor is the WebAssembly part. Okay, so we will see how to create a simple Blazor project, etc. To answer the question, what are some steps required to go from ASP.NET MVC core to a Blazor app? It will obviously depend on the kind of app you're doing, but the fact is you're already have your code base in .NET Core means that you will be able to share a huge part of your web or of your code base onto Blazor, either server mode or WebAssembly mode. But do you want to do the migration? And that's another question, because you may want simply, maybe the best solution is to basically stay onto ASP.NET MVC and just migrate from ASP.NET MVC 2 to X to ASP.NET MVC 3X. Maybe only part of your experience should be built on WebAssembly, and some other pages of your application should stay into ASP.NET MVC. So yeah, the first step will be to evaluate when you need a rich interaction within your application, on which pages or which areas of your application. And when you have identified some of these areas, then you can try moving onto Blazor. And from code perspective, Blazor is based on Razor. So if you're already using Razor as a view engine, it should be quite easier for you and your developers to move over to Blazor if it's needed. Yeah, so what is Blazor? Let's check out the demo app. So for this, I will switch off my camera for a few seconds because I will need to display the camera on my web browser. You will see it. So I have my project. I will just start it, and then we will go into details about how I've implemented it. So here is my web page, and when you're starting the exam, you're starting from an email. Okay, so the students receive an email with a link and a huge code. We will go into details about what's within this link, but I click here and I should be able to start my exam. So I've registered you, Brian, as a student, and I need a few information: first name, last name, and a fake email. Sure. And the next step I wanted to have is a picture of you to ensure that you are actually taking the exam and not me taking the exam for you. Okay. So we will go click on next, and then hey, I have the camera that is up and running within my browser. It's the HTML5 camera APIs. So I'm using this camera, and I wanted to take a picture of the candidate at that time for two reasons. First, ensuring that the proper candidate is actually taking the exam. And the other one is because when we issue a scuba diving card, we actually need to have some picture of the student on top of it. So that's also a way to actually get that image. So I don't need to later on ask the student again for a picture. But I wanted to have a good picture, not, for example, a picture with a hat, because it's not like a proper ID picture. So if I take a picture with a hat, I should have a warning that say, hey, you should not wear anything on your head. Or if I take a picture with some sunglasses, I should have, if everything is working, also an alert saying, hey, you should remove your glasses and you should look at the camera. So we will dig into details about how I've built this experience. I will try to take a good picture at a time. Cheers. And that seems okay. And then there is kind of a legal contract. The fact is to adhere to the standards of the diving agency, we need to ensure that all the answers are collected and stored securely, etc. And you agree to all of this. So I've built a small experience where you have like a basic contract things, and you need to actually sign this. And if I click on next, I have a breakpoint still running from my previous debug. And then I done something, but we can talk about things I want to improve in this project later on. But the idea is all students in the group to start the exam at the same time. And I did a time to build a live experience. So my idea was to basically every student go on a Teams call, and when everybody is at this stage, I can give them shout out loud an access code, and people will start enter this access code. And so at the same time, more or less 1 or 2 seconds, they enter the exam at the same time. So I will enter the exam code, and boom, the website goes full screens, and I have the exam with the question. Oh, I miss the first one because I have like 5 seconds to answer them. And I click on next, and then I have the answer, like the results. So that's the whole experience I've built. So maybe the first thing we can look at is different components of the application, different part of the applications. So obviously, the first part is a Blazor, the Blazor app. So I have here my Blazor project, and we will see how a Blazor project is organized in a minute. And then I have an Azure Functions project. So at some point in time, I will need to actually store things in the cloud. Like I need to store the answer, and I need to store the signature and the picture. So I created an Azure Function project to expose some APIs to actually do all of those things. One of the cool things of Blazor is, as everything is .NET, I can actually have a shared project, which is my Blazor quiz model project, where I have all the classes with all the data I need from the client side and the server side, actually shared in one project. So I don't need to copy paste code or to reuse code. Basically, I'm just, and you will see it's very easy to post a JSON to an HTTP API from Blazor, and it's as easy to parse it from Azure Function. So that's also one of the very cool things of this setup is that very easy to build, to quickly build prototypes or applications with a REST API in the middle with Blazor. And I also have a small project. We will go into this detail. It's a small console application, but I will talk about it later on. So to give you also a bit of perspective about what we will see and the kind of features I needed to actually think about and how I've built them. one of the features I needed was to authenticate the user. So I need to ensure that you, Brian, are actually connecting to the application, and I need to authenticate you for contract purpose, because you need to sign off your exam sheet, and there is a lot of different ways of doing this. So we will see how actually I've done this with things called GW2 tokens. And by the way, how to send emails from Azure function. So the email you just saw earlier. Then we will see how I made the experience about actually taking a picture from the Blazor web app and trying to understand if the picture is from good quality or not, based on Cognitive Services Face API. And then we will see a few interesting features about storage account in Azure that allows me to basically create an electronic signature storage system. You will see with very few lines of code to actually store your signature and your picture in an immutable way and secure way. And we will talk about other things I wanted to implement at the end of the stream. Brian, I think you taught it, but if you have any questions, do not hesitate to ask them on the Twitch chat.
Yes, please. Yeah, any questions, just drop them in there and I'll relay them, or Christopher will see them. Thank you.
So maybe the first thing we can talk about is actually how to authenticate the user, and this is needed for a very specific need. Is we need to create a legally binding contract between you and the results and the diving club. It's something that is required by the diving agency. So there is a lot of different services out there to actually, sign a PDF online without having to exchange paper documents, etc. But they are not cheap. They are fully featured with like you can sign on 3 different pages, and you can mark your initials, etc. And I don't need all of this for this specific project, but I need to ensure that I'm storing the fact that you are consenting to doing this exam online, and you are consenting that I'm storing all the exam data for a specific period of time. So if you look at this, and I'm not a lawyer, so I may have done some mistake along the way, but there is different laws in the US and in Europe as well around it, and basically they have 3 to actually create a legally binding contract digitally. You need to adhere to 3 principles. The first one is intent. The second one is identity, I think, and the third one is immutability. Intent is basically that we are both agreeing on the terms of the contract. Identity is I need to prove that you are you, and you are actually adhering to the intent. And immutability is basically I need to store these things in a secure manner, so nobody can tamper the actual signature. Okay, so that's why I need to authenticate the user in my application on top of the first name and last name. So there is different ways to actually do the ID, and one of them is to actually exchange a code between the parties. So it's something we do, I would say, every day. You input your phone number onto website, and you receive a confirmation code or validation code by SMS, and you input that code onto the application again, and that way you have proved your ID in a more or less secure manner. So what I wanted to do there is to actually do this, but by email, to reduce the costs. So we will see now how we can send an email from Azure Functions, how you can use the GW tokens to actually authenticate the user from the client side without having to connect to the server. Okay. So let's get to my Azure Function website projects, and I have the exam admin function class. I think the font size is okay, but if you have any, if it's too small, do not hesitate to tell me. So how do we send an email from an Azure function? Actually, is very, very simple, depending on your provider. So there is a lot of different providers out there to send emails. One of them is SendGrid, and it's integrated in Azure. That means that you can create a SendGrid subscription within the Azure portal. So it's very easy to get started. And basically, when you create this, you get a SendGrid API key. So very basic thing. So what I've done there is I've created an Azure function that is triggered by an HTTP. That means that this is exposed as a REST API. And when you send a specific object, the exam invite view model, we will see this in a minute. I will actually create the audit log, and we will see that in a second part of the stream. I will create that email verification token I told you earlier about, and then I'm creating and sending the email. So we will see all this code later on, but to actually being able to send an email from an Azure function, you need to add this line of code that gives you a parameter to send one of or several email messages. You need to create a SendGrid message object, and as you can see, it's very easy to do. You need to add someone to receive an email, a from address, a subject, and a content. I've created some helper methods to generate this, but it's very dummy code. And actually, you just need to call this to add the SendGrid message to message collector. And that's it. With only these, I don't know, 5-6 line of code, I'm sending an email from an Azure function to SendGrid. So all the underlying architecture plumbing is actually done by the SendGrid Azure function extensions. So that's one of the cool things of Azure. And actually, you can develop your own extensions. So let's means you want to send data to a specific service, specific application within your company, and you're planning to create 100 of Azure functions that will communicate with this specific service. You can actually create your own Azure function extensions. So all the developers will actually write very few lines of code to send data to that application. So that's one of the cool things of Azure Functions, and that's it. When I said when you receive the email, you'll receive something like this, and as a student, as a user, you just have to click here to actually access your online exam. So now we can look at what's actually is within this link, because it's where there's a bit of magic happening. So as you can see, I know it's a bad practice. I've as a website URL in hard coded in the code, but I'm actually writing this code right now. But basically, if we don't look at this, because this is bad code, this is okay. We have the exam invite code. So if I open up the website, as you can see, I have my test exam is actually the name of the exam, a slug for the exam. And then I have a code, and I have a long string with a lot of different things. And this is actually a GW2 token. So if you don't know what is a GW2 token, one of the best side to learn all about GW2 is actually gw2.io, which is the one of the websites to explain what are JSON Web Tokens, and it's basically a method to securely exchange claims between parties. So if you know OpenAPI, OpenID, sorry, OpenID is based mainly on GW2, and to give you some example of what's inside this very long string. Basically, you have a header explaining the type of token and the signature or encryption algorithm. Then you have a payload, and this is where things could be interesting, because there is some predefined values, but you can also extend these values to add whatever you want within this payload. And then you have a signature with either a secret, and in this example, we are using a secret, but you can also use a public-private key pair. That means that if you as a software, you're generating JSON Web Tokens, and you want another party to verify that you have actually issued a specific token, you can just give your public key, and anybody can actually verify that a specific token has been issued by you. So it's something very very easy, and at the same time very powerful. So what I've done in my project is I've created a method, and all of these things are a basic standard .NET code. You just have to add a specific package, which is System Identity Model Tokens GW2, to get access to some specific classes. But basically, I've created a token with a few claims, like the first name, last name, email of the student, and also his ID or her ID, and a student verification token that is only used to actually adhere to these second principles for legally binding digital contracts. So everything is standard except this one, and the ID. The ID is also a custom claim. And what I'm doing this now is using a symmetric key. So it's a key I have there. Again, very bad security practice. You should store this elsewhere. But I'm in the middle of actually crafting this part of the code. And what I will do is I will actually parse this JSON Web Token from the client side. That means that when I arrive as a student on this web page, and you see Brian Benz and your email, actually all this information gets pre-populated from the token itself. So the student doesn't have to write something to get started. So what we can do is to actually run this code to see how it's done. And I will use Postman to actually test this. And maybe we can change the name to show you that this is something working. And trying to get a colleague pass the scuba diving certification. And send. So I will receive an email in a few seconds. I can show you the email when it arrives in my mailbox. but I have output the token right here. So I can go there, test exam, and code this, and we should see the Frank name. Yeah. As you can see, we see Frank informations appearing there. So you saw how I've created the token on the server side. Oh, I just received the email. I can show you it's the email.
I want to jump in and say as well, neither Frank or I, those aren't our real emails, so
yeah,
don't try and send them. It might go somewhere else to someone else. I don't know, but anyway.
Good catch. It's
it.
fake emails. And yeah, as you can see, the email is personalized, and if I click here, I will be on the same address. So we saw how to generate this GW2 token on the server side. Now we need to understand how I can read it from the Blazor client side. So let's jump in the Blazor website, and actually I have a specific page which is this one, start exam page, which is like the landing page for the exam, and we will see how a Blazor web page looks like and how I can do that kind of interactions, rich interactions within this web page. So this is Blazor applications are mostly Razor code. So this is a Razor page. We have some directives. One of them, the add page, is a way to manage the routing within your application. That means that when my website is loading, the Blazor navigation system will actually try to show this page because the current address is in this form. So for example, the exam results page is only /results. Okay. So it's very easy to have different pages, and when you're navigating from one page to another, the actual address on the browser is also changing, and all the browser features like you want to add a specific page into favorites or you want to go back, etc. They should be working depending on what you're doing on the state, but everything is working. So from a user perspective, they don't really see a difference between a Blazor app and an ASP.NET MVC app, for example, except maybe it's richer and quicker. So that's one of the cool things. And as you can see, Blazor web pages are basically HTML pages with some code in it. So we can do pretty much everything. We see more advanced scenario later on. What I need to do is to parse the URI and extract the code part of the query string and then decode the JSON web token. So it's a bit of code to do. So within a Razor page, you can actually have code inline. So this is an example. If you create a new Blazor project, you will have this page fetch data, and as you can see, there is an add code block, and then you can directly have some code in it. That's cool for small pages, but only do very few things. But like the exam page, the start exam page is quite complex because it's within this page that you go from inputting your first name, last name, then capturing a picture of you, then signing a document, and then inputting your access code. So there is a lot happening into this page, into the start exam page. So what I've done is I've extracted the code to its own proper C# file. So actually, the experience you see from the start page is based on two different files, code files. The first one is a Razor only file, and the other one is the actual Razor.cs classic C# file. So, yeah, sure.
Christopher, I just want to jump in. I know we're showing things in Visual Studio right now. But you can also, if you don't have access to Visual Studio for licensing or whatever reason, Visual Studio Code also uses Blazor as well, correct? You can build a similar application at least. Yes.
Absolutely. Here I'm in Visual Studio because it's my de facto environment, but you can definitely create Blazor app within Visual Studio Code, and with Windows or Mac or Linux or Windows subsystem for Linux, what do you want? It's pure .NET Core multi-platform framework, so you can definitely do this, or even online. There is if you want to use Visual Studio Code Spaces, there is a few things you need to adjust, but you can do pretty much whatever you want.
Cool. Yeah, we had a comment. Beldathas, don't know if I'm pronouncing that right, says, yeah, he's been using Visual Studio Code for Blazor on the Learn platform, and we'll share some links for the Learn platform and follow up with this later. But yes, and the other answer is yes, Christopher is French.
Correct. Bonjour à tous. Hello, everybody. So yeah, so the next thing we need to do is to actually grab this this piece of code within the query string, and for this we actually use this specific override. So I will not go into too much details because we have a lot to cover. But basically, there is a life cycle of a Razor page, and one of the first piece of code that gets executed is this on after render async method that you can override. And actually, each time you're changing something to the page, this specific method get called again. So I'm doing a trick here to say I only want to execute the following code if I am on the first render, so basically when the page loads up. But if something changes on the page, I don't want you to execute my code. And when I'm on the first render, what I'm doing is loading the exam. I can tell you a little bit more about this, but it's basically loading the exam information like title, logo, and questions, actual questions. And then we get to the interesting part, which is actually getting this GW2 token and parsing it. So the first thing I have created is a short method to get the access token from the URI. It's very easy. We have an object, the navigation manager, that gives us the actual URI of the web page. And then we have a query helper to actually get the value. So it's quite easy code. And this is from ASP.NET Core. So if you're already an ASP.NET Core developer, you may already have used this class. So if I go back to this, when I have the string from the query string, I can just use the read GW2 token method from the GW2 security token handler method to actually get an object that allows me to get the information from the token. And as you see here, I'm getting all the properties from the payload. So actually, if I go over and I copy this token and I go back to gw2.io and I copy paste this, as you can see, I have all this information there. So it's really standard, and you can actually create a GW2 token from, I don't know, a Java function project and parse it from a C# Blazor project. But I think that's quite cool. And when I've done this, I'm just setting up a current candidate object with all this information. The next thing I need to do is to actually display this information onto the web page, and that's quite easy to do. I will show you how to do it in a second. And what I've done is because my page was getting bigger and bigger, I've used another cool feature of Blazor, which is the components. So basically, components are a way to encapsulate the UI and the interaction into a smaller component to compose your UI. If you're doing Angular or React or other front-end frameworks development, you should be used to that thinking, and you can actually do this with Blazor as well. So I created a small component to actually display the first name, last name, email. And as you can see, that's very easy to bind an HTML object to value within your C# world. I just have to bind it and then give the path to that object. And with this, I've done my first step of sending an email from Azure function and authenticated the user from the client side.
Hey, one of the things I'll add, when you use Azure Functions, one of the advantages is not only that it's easy to set up, but also that it scales really well. So if, for example, Christopher all of a sudden had 40,000 members of the of the scuba diving club, it could easily handle all of those emails with the application. So it's a great way to scale things on the front end. So
definitely, yeah. So my next challenge is to actually get a great picture of the candidate. And I had that issue many times where people were sending picture where, you know, you're giving a hug to someone and you cut the picture half, so you have half of an arm from somebody else, or you have part of a face from somebody else, or people are not looking at the camera, they are taking a picture like this. It was horrible. So I wanted to have kind of a self-service great ID picture system, and to do it on mostly on the client side. Again, I don't want to manage the load on my server, so I've used a different components to actually do this. The first one I will show you is the Blazor JavaScript interop, that basically allows you to get access from Blazor to whatever you want in the JavaScript world. So if there is an API that any JavaScript application can access to, you can access to it as well from the Blazor world. And the other service I will use is one of the cognitive service, Face API, to actually get data, get information from the picture itself. So let's go. Let's see how I've done this. Let me close everything so we get a clear state. So first, to be able to use the webcam from an HTML application, you should be on HTTPS. It's a requirement, security requirement from a lot of different browsers, and you will have a prompt to actually authorize the first time, to actually authorize a specific application to access your webcam. And then the idea is not to stream everything from the JavaScript world to the C# world. You will see why in a minute. So basically, when I'm displaying the camera, everything is done on the JavaScript side, and only when I'm taking a picture, I'm doing some communication or some interrupt between the Blazor world and the JavaScript world. So because this is quite complex experience to manage, again, I've created a specific component to do all of this, including calling the Azure Connective Services. So this is what my Blazor code look like. If you have already done HTML5 web camera things, it's very, very basic HTML code. I have a video and a Canva tags. I also have an image. So basically, when you take a picture, I hide the video element and I display the image element with your image. Then I have a button to actually take a picture, and if there is some issue with your picture, I'm displaying the list of issues there, and I have another button to actually retake the picture. Okay, so that's very very basic HTML code outside this small C# codes to display buttons and things or not. And then I have a bunch of different codes that actually do the JavaScript interrupt. And that's one of the cool things we have. So basically, you can have C# code that will call a specific JavaScript method, or you can have JavaScript method that will invoke a .NET code. It works both ways. The fact is you cannot trust the JavaScript side of things. So I tend to prefer that my C# code call a JavaScript function and get a result out of it. I could have built the experience differently, like the take picture button, all the interaction could have been created in JavaScript, but I prefer to do it that way. So as you can see from my C# code, I'm invoking the webcam stop method, the start camera, the take picture. That one is interesting because I got string as a result. So we now need to switch to the JavaScript world to understand how these methods are declared and how they can be accessed from the Blazor side of things. So for doing this, I will go on the www root folder, and I will go on my index.html. So yes, there is an HTML file when you do Blazor, and basically that's the bootstrapper HTML file. So if you need to reference any CSS file, you will do it there. If you need to reference any scripts, you will also doing it there like any other HTML application. And when Blazor has boot within your web page, then the content of the app element will be replaced by whatever you have within your Blazor application. So what I've done this is I've used an existing library, the Webcam Easy JavaScript library, and I've also created my own camera.js file to give me just a few helper methods. So when I'm doing start camera, it assigned all my different elements, create with webcam objects, start it, that kind of things. So you can look at this code on my GitHub repo. Again, there is no, like even me, I can write this JavaScript code. So that's quite easy to understand. And I only have 3 different methods: start camera, take picture, and retake picture that actually change what is displayed or not. Okay. Yeah, you have a question, Brian?
Yeah, I was just going to say, adding a few things. So today we're showing how to access the APIs versus via JavaScript. There's also .NET, Python, Java, Node, Go, iOS. And you can also access it by PowerShell, believe it or not, and the Azure CLI. So there's a whole bunch of different ways. I did put a link in the chat that shows the different APIs and the different documentation. There's some snippets in there that help you, some helper classes and things in there already. And we did have one question, and I don't know, I think this is more of an AI question that I can't answer, but I'll take a shot at it, see if we can. Can you use a local trained model like Onyx and use it instead of calling cognitive services? I suppose you could. Nothing's stopping you, but the cognitive services, you have this huge benefit of accessing incredible amount of information that is the base of every response you get. Literally millions of face records that give you responses. And this is only a small subset of things that you can retrieve. You can retrieve person's age, whether their gender, all kinds of things can be retrieved via the model as well. So there's a lot of stuff out there that you can use. Anyway, please feel free to jump in, Christopher.
Sure, absolutely, you're right. You can, the fact is, you can convert from, depending on what you're doing, etc., but you can convert an ONNX model to a TensorFlow JS model, so a TensorFlow JavaScript model, and you can run the inference phase within the JavaScript world. So you can definitely combine this with Blazor to actually run these things. One of the other things I didn't explore, but we have a ML.NET library, so it's a pure .NET machine learning library that I think there is some compatibilities with ONNX at some point. I'm not an expert in this area, so we may need to check out other colleagues. And I'm pretty sure you can use ML.NET from a Blazor app as well. So yeah, definitely that's something you may want to do. Why I've chosen cognitive services. So if you don't know what is cognitive services, is actually a set of services. There is like dozens of them. If my keyboards get up again, I may be able to type azure.com.
I'll post a link as well in the chat.
So there is a ton of different cognitive services, and the way I present it is AI for people that don't know how to do AI. So basically, if you want to detect an anomaly on a time series, if you want to extract some sentiment from a text, or in my case, if you want to learn something from images but you don't know how to do AI, for a basic usage, you have probably a cognitive services to do it. And that's exactly what I've done with the Face API, because one of the things I wanted to do, and I will actually stop my video camera on the feed to show you how I've done this. So I've used the .NET Cognitive Services Face Client SDK. So basically, I've only have to execute this. Face Client detects faces with stream, and I'm passing a stream with the image data, and then a list of attributes I want to get from the service. I don't need the age or emotion or gender or hair. I just need to be sure that there is no accessories like hat or glasses, no noise, no occlusion. So if I put something over my my mouth, I don't want to accept the picture, or if the picture is blurry, I don't want to accept it. So that's the only things I need to do, and I don't need to train a model. If I wanted to do this on my own, I will have to train, I think, quite complex model. So for this specific use case, it's, I think, easier to call the Face API. But if you want to detect, I don't know, a range from another tool, maybe you want to learn more about how to execute your own model. So one of the things I wanted to show you is this debug mode. So you will see the actual answer from the Face API service. So let's put my Cloud Advocate cap up, take picture. And what you can see here is actually what the Face API's answer is. So they detected only one face. They give me the coordinates of my face within the pictures. It seems that I have some beard and mustache, and that's correct. I have something in my forehead, my cap, but nothing else. And I have some accessories. So there is a list of accessories. So 0 means hat or cap. And as you can see, there is quite a good blur level and good exposure as well, and no noise. So I have no issue on that side. But for example, if I try to retake the picture and move quite quickly, and we may see some blur level, yeah, up there, from like nothing to more than 30%. And one of the other things I'm using there is a head pose, which is quite useful. It's basically the way you're looking at the camera. So that helps me ensure that people are looking straight at the camera and not looking from the side of the camera. So it's very easy to build things like this with Face API. Maybe a word about security. I'm calling. Let me get the demo up there again to show you something interesting. I will show the developer extension because that's something people don't think about when they think about Blazor, when they discover Blazor. But actually, let me remove all of this. Actually, the Blazor app is web app, so I can inspect everything in the web app. And if we look at the network, if I click next, my camera is open on another browser. So that's a shame because you cannot actually. Let me display this there.
There it is. Hey, I should mention. I'll just jump in real quick. This is Microsoft Edge as well. So these are the dev tools for Microsoft Edge that Christopher
correct.
Showing. Yeah.
So I'm taking another picture there, and as you can see, you can inspect all the traffic from the Blazor web app directly from the browser. So the fact is here, I'm calling the cognitive services with my billing key from the browser. So that's working, but definitely something I want to do in the future is to actually not call the endpoint and showing to everybody in this stream my real subscription key, but actually calling an Azure function and store this sensitive information within the Azure function itself. So it's just to show you that it's working, but if you want to implement that in a real world project, I would highly encourage you to not calling the Face API directly from the client side, or maybe you're just within your company network and you think it's not an issue, but yeah, that's something I need to change.
Yeah, let me add as well, not just a function, but if you want really good purpose-built security for things like this, we have Azure Key Vault as well. Obviously, this is a PoC app, and this is the most flexible thing to do because it's easy to update, but I'll put a link in the chat for Key Vault if anyone's looking for more info on it.
So I think we've saw quite quickly how to do JavaScript interrupt. Not all scenarios, but you saw that it's quite easy to actually call a JavaScript function from a Blazor world, and it's also easy to call a Cognitive Services API from Blazor. So I don't know if there is other questions, but if no, I think we can jump onto the next topic around the signatures.
Nothing at the moment, so yeah, feel free to
continue. Okay. So my issue there is, as I said, I'm creating their token with confirmation code. And I need to securely store that you've started the process, I've verified your ID, and you signed it, and doing all these things, ensuring that nobody can tamper the records. So again, if you're doing this on a real-world project, I'm not a lawyer. I won't be able to. Let me switch back and display my camera on the feed. I won't be able to ensure that if you're following this, you will comply to all rules within your business. But I wanted to highlight two cool things. One is around Blazor, and with all the components that's starting to show up in the community to accelerate the Blazor development. And the other one is cool features around blob storage, because I think the blob storage is a very underrated service. We use it to store files, but we can actually do a lot of different things and a lot of cool things with blob storage. So let's jump in onto this specific part. And to show you this, let me connect to my Azure portal. I will open it on a side to get the proper portal and not the internal one. And I will show you how I done to actually store securely all these informations. So this is my Storage Explorer, and I think that one, yeah. So basically what I'm doing is for any kind of exam, I'm creating a new container with the name of the exam ID, okay? And then I have a subfolder for any student. And within each of these folders, at the end of the process, so when you are actually starting the exam, starting answering the questions, I should have these three different files. I have a signature file, which is the PNG file of your ink signature. I have an ID, which is the picture. So if I download it, you should see a picture of me earlier today. Yeah, that's me. And within evidence, the evidence file is basically a file containing several JSON documents that allows to retrace the history of the digital signature. So I have a timestamp, I have a type, so I can identify the different steps on the signature, like creating the package, creating the verification token, and actually sign the contract. So when you click on next, after digitally sign the contract, I storing this and storing other piece of evidence like your IP address. Beware to all the personal information, raw and compliant, etc. Again, I need to store these things for my specific use case, but you need to check out how and how long, etc. You need to store these things on your specific use case. But it's just a simple text file. So how do I ensure that nobody will actually modify anything? That's my first question. And my second question is to adhere the US Diving Certification Agency standards. I need to store all these informations for a duration of 7 years. So that's quite a long time. And if somebody happens, I cannot say that, hey, maybe a developer go over and click on delete of these files and we lost 2 months of records. We need to have the full history and to be 100% sure that this history will be stored in the future. And for doing all of this, I'm actually using very specific features of the Azure storage. So let me go into my storage account and show you a few different things there. So the first thing people don't really know about the Blob service is the data protection feature. Actually, if I go over and I click on enable blob stuff delete, when you are actually deleting a blob from your storage, from whatever the means you're using to actually delete your blob, it could be the Storage Explorer, it could be the Azure portal, it could be a piece of code, whatever. Actually, Azure will keep your file for an extended period of time. You can define it from 1 day to 365, I think. Yeah. So that's a way to prevent accidental deletions. So you click on the wrong button on the interface, and suddenly all your data are gone. Then by using the blob soft delete feature, you can save the day. But here I need to not only ensure that the file will not be deleted, but the file will not be tampered as well. And then for doing this, I will use two extra type of data storage features. The first one is I have created an append only blob type, which means that actually Azure will prevent you to modify anything in the file. So basically, you can add new content on this file, but you cannot delete anything. You cannot modify anything. So that's cool for logs, for example. So you ensure that nobody will remove a few lines of logs. So that's a way when I'm creating the blob storage, the blob file, if we go to function, exam admin function, you can see here on the specific methods that I'm using the C# Azure Storage Client, and I'm creating an append blob client. And on the subsequent calls, I need to use the append blob client, and the only thing I can do is to append the block confirmation. I cannot modify or delete. I cannot modify any existing data, but I still can delete some data, and that's one of the other issue I had with this feature. So I needed to find a way to securely store something in blob storage and ensuring that nobody will be able to delete a log at all. And that came from another feature within the containers, which are the access policies. And within the access policies, we have one of the type of policy, which is called the immutable blob storage policy, that basically does this. It's transform all the data within this specific container into a non-modifiable and delete protected state. So you can store things on this container and nobody will be able to delete it or to modify it for a specific period of time. And it's guaranteed by Azure. We have some compliance certificates for a financial industry around this feature to ensure that nobody, and even if you're the owner of the subscription, you will not be able to delete this storage account or the container or whatever. So I can definitely go there, and I am the master admin of my subscription, and click on supprimer, which means delete in French. And actually, are you sure you want to delete all these objects? Yes, but the action will be refused in a second. Yes, as you can see, the action is refused. And actually, if I open the logs for this, you will see that this operation is not permitted as the blob is immutable due to a policy. Yeah. So even if you're root, you cannot delete anything. So that's precisely what I needed, because I wanted to be ensured that even me, I cannot delete these legal documents if I wanted to do it.
By the way, it's as a somebody who plays around with Azure frequently. Yeah, this is one of the most challenging parts for me is if you make the wrong steps, you've got this thing you can never get rid of. So actually, it's very careful. You need to be careful setting up your policies for sure. Also, access. I was going to say as well. Access, and these are good things I'm describing, by the way. But access, sometimes when you're a PoC developer, just trying to develop some quick thing, access can be a challenge as well, because it's actually these are pretty well locked down by default. They're very, very secure. So it's a good thing, but it's a bad thing for developers sometimes. That it's a challenge to get in there.
and actually, I wanted to touch a word about this. There is two types of immutable policies. The first one is the legal hold. So let's say there is something happening in your company and you're starting a trial, but you don't know when the trial will end. You can actually create a legal hold with a tag, and tag could be, I don't know, the claim number or reference or whatever you want. And so you can remove the legal hold in the future, or you can choose a time-based retention, which is obviously what I've choose there. And then you're telling a number of days. And I told you that I need to store these documents for 7 years. But when I'm doing some tests on my development account, I only have added 3 days because actually I will not be able to delete anything if I add some data or create some document for 3 days. And it's exactly. This retention interval is calculated per file. So if I say 7 years and I create a new file in 1 year, the new file will be deleted 7 years after this creation, and not 7 years after the container creation. So definitely you need to be careful when you enter something in that field.
Yep. Hey, I wanted to let you know you've got about 13 minutes left as well.
Yeah, great. So basically, the only thing I've done is I've created a log format to actually store all of these things. Let me jump there. And basically, nobody can actually delete all these things, and I can prove that nobody has modified either your signature, your ID, the date. Is the last modification date is done by Azure, so I cannot tamper anything like this. So I kind of have proved that you're agreed to this contract. And one of the things I wanted to add there in a future release of YAP is to actually store there your results, your exam sheet. So if in 2 years I need to justify that you've answered correctly to this question, but not correctly to that other question, I will have all this information there. And the last thing I wanted to add there, I haven't done it yet, but I will do it definitely in my next iteration, is actually using the lifecycle management system to actually move automatically the blob storage to a different tier. So that's also something that people don't really know about Azure Blob Storage when they start using it. But we have different storage tiers that allows you to basically pay way less when you need to store data on the long term while not really needing it. So basically, I need to store for 7 years all these records, but maybe, I don't know, one student out of 200 will need my actual data about them in the future. So one of the things I want to do is basically during the months after you passed or failed your exam, you will have access to this data very easily. And after that, I will automatically move all this data to an archive store to pay less. And if I need it at the moment, yeah, it could take a few hours to get back this data, but for several years, I will pay less. So that's also a cool feature, I think, for Azure storage, and specifically when you need to store for a very long time this kind of legal proofs type of documents. So yeah, I've let's go back to this. And I wanted to show you the Blazor component very, very quick, and we will be just on time. Close all documents, get back to my project. And yeah, one of the cool things of Blazor is I feel that the community is starting to be interesting and starting to look at Blazor, and specifically Blazor WebAssembly, since we released the RTM version at Build. And we can start to see a lot of different community members, open source projects, and even or historical partners like Infragestics, DevExpress, Telerik, and much more, creating advanced UI components for Blazor. And one of them is an open source component called Signature Pad. So actually, to add my signature pad and using the Canvas APIs and Touch APIs from HTML5, I basically write almost no code. The only thing I had to do is to add a NuGet package, because yes, you can add a NuGet package from to a Blazor WebAssembly web app. So I've added the signature pad NuGet package, and I've added these components. And the only thing I had to do on the other side of the code was, let me jump to next page state. Here is this is very easy to actually take the signature image and send it to Azure to store as a blob storage. So here is a reference to my signature components on the Blazor side of things. They come with a handy method toData URL, so I get the actual image content as a PNG file. And I've just had to create an upload signature picture method, and I wanted to dig for a few minutes onto this method, because I'm doing something interesting. And again, people that are discovering Azure don't know that these kind of things are possible. But for
hey, Christopher, sorry, I just want to jump in real quick. Do you mind turning your camera back on, unless you're going to use the app?
Oh,
somewhere? Yeah.
No. Sorry, I forgot. Okay. I'm not used to have my camera hooked by some HTML web page.
Yeah, I know. So it takes a while to get used to.
I need to find actually which window, which browser window is actually grabbing my camera.
It's no big deal. I just wanted, in case you wanted to do it, it's up to you.
I will try to do it while I'm explaining all of those things.
Okay, cool.
That's weird. I don't know where it's going. Can I turn it? Okay. It should be on now. Let me turn it off and on again. It should be on. It's on Skype at least.
I don't see it yet, but that's okay. It's no big deal.
Yeah. So one of the things I wanted to do is, as you said, I've used things to actually reduce my load on my server. So one of the things I wanted to do is when I need to upload a picture of the candidate or the signature, I don't really want to send all the data onto a server API and then copy that data onto blob storage. So what I've done is I've used the SAS token feature of the blob storage to actually send the data directly from my Blazor app to the Azure storage account in a secure manner. So how I'm doing this? Actually, the blob storage is simply a REST API. So you can here execute a PUT HTTP requests to the blob storage. And the only thing you need to have for actually doing this is a SAS key. And actually, within my Azure Function project, I've created a little methods to actually generate this shared access signature for a limited amount of time, and to send it to the client side. So it's very easy to execute this because this Azure function doesn't need anything to execute. There is no dependency at all. You don't need to actually ping the blob storage service to actually generate this signature. You can do it in memory from the function side. So no dependency there, and I send all this information to the client side, so I can upload all of these things directly from the client side. So that's a way to remove some traffic from your server side as well, and sometimes improving the performance of your application along the way. Yeah, so I think I've showed you everything I had today for my little Blazor app.
Beautiful, thanks. That was extremely useful. I apologize to everyone for the occasional video and audio issues. Live streaming, live data, live demos. So sometimes this happens, but yeah, this video will be here on Twitch TV on the Microsoft Developer Channel for a few days, and it will be on YouTube at the Microsoft Developer channel there as well after a few days as well. I've put the links for the YouTube channel in there. I assume you know where this is if you're here. And I've also put some other links for blob storage, cognitive services, Christopher's repo, and a bunch of other things that Christopher's been describing as we went along. So thanks everyone for coming. If anyone has any additional questions, we've got a couple of minutes. Otherwise, thank you very much. And thank you, Christopher. That was wonderful.
You're welcome.
All right. Okay, I don't see any more questions, so I think we'll end it there. So thank you.
Thank you. Have a great day.
Thanks.